This module will cover a very important concept in decision analysis, which is value of information. In particular, we will evaluate the value of information through expected value of perfect information and expected value of sample information. So what is value of information? Information is valuable when that information can lead to a choice or a decision that is different from what we would have chosen when we do not have information. In other words, we can think of the value of information as a difference between the best anticipated payoff when we have and don't have the information. Or think of it as how much we can gain when that information becomes available. So why do we want to calculate the value of information? It is because we want to evaluate whether it is worthwhile to put in resources to get additional information in our decision analysis process. We want to know whether it is worth the effort or worth the money to consult an expert, do a test, or perform a survey for a better prediction of uncertain outcomes. In decision analysis, we evaluate the value of information through two different metrics. The first metric is the expected value of perfect information. We said that an expert's information is perfect if he is always correct. If someone can predict the uncertain outcome with 100% accuracy, then this person has the perfect information. The concept of expected value of perfect information is to calculate what is the amount of increase in the expected profit if the decision maker knows which state of nature will occur. We can also think of expected value of perfect information as the maximum amount of money that the decision maker is willing to pay to obtain such information. So how do we calculate EVPI? We need to know the expected value with perfect information and the expected value without perfect information. The expected value with perfect information is calculated by finding the best payoff among the decision alternatives under each state of nature, then weighted the payoff by the state of nature probabilities. In other words, we calculate the maximum expected payoff. You can also think of it as the expected return when we can always make a decision that has no regrets. The expected value without perfect information is the expected payoff of the best alternative when we do not have perfect information. In other words, we can simply use the prior probabilities to find the expected payoff of each alternative. And because we will choose the alternative that has the highest expected monetary value, the expected value without perfect information will be that alternative's expected monetary value. Let's look at the following example. Let's start with the scenario where you do not have perfect information. You are choosing between two options, to play or not to play. If you decide to play, then there is 50-50 chance to get a head or a tail. The corresponding payoffs are $10 and $6. As the result, the expected monetary value to play the game is $2. And the expected monetary value to skip the game is $0. Therefore, you will choose the alternative with a higher expected payoff, which is to play. Hence, the expected value without perfect information is $2. Next, we consider the scenario where you can obtain the perfect information before making your decision. Dave may tell you the flip is a head or a tail. If Dave tells you that it's going to be a head, then your best choice is to play the game. Similarly, if Dave tells you that it's going to be a tail, then your best choice is not to play the game. Because you will make your choice based on what Dave tells you, and Dave is 100% accurate. The expected payoff when you have perfect information is 10 times 0.5 plus 0 times 0.5, which is $5. Now, we can calculate the expected value of perfect information, which is 5 minus 2 equal to $3. This is also the maximum amount of money you are willing to pay Dave to get his information. Next, please try an example on your own.